You know that moment when you get your car insurance bill and you just stare at it, wondering how in the world did they come up with this exact number? Well, I can tell you it is definitely not a random guess. Today, we're going to pull back the curtain on this super powerful statistical engine that insurance companies use to figure all this out, how they predict risk, and ultimately calculate what you pay. Okay, so think about it from the insurance company's perspective. To them, you're this totally unique combination of risk factors. You've got your age, the car you drive, where you live, your driving record. I mean, all of it goes into the pot. But the real question is, right, how do they take all that stuff, all that data, and boil it down to one single dollar amount? And that is the huge challenge they're up against. I mean, they need a system that can handle millions of people, each one different, and spit out a price that's, fair to you, but also keeps them in business. It's this massive, massive analytical puzzle they have to solve.
So what's the answer? Well, for the past few decades, it's been a statistical tool with a kind of boring name, honestly. The Generalized Linear Model, or as everyone in the biz calls it, a GLM. Don't let the name fool you, though. This thing is the absolute workhorse of the insurance industry.
All right, so what exactly is a GLM? Think of it like a really, really smart forecasting tool. It just digs through mountains of historical data, looking for patterns. Its whole job is to connect the thing they want to predict, what they call the target, so say the cost of a claim, to all the things they know about you. You know, the explanatory variables, your age, if you're married, what kind of car you have, all that.
Okay, so how does this thing actually work? It can feel like a total black box, right? But the logic at its heart is actually pretty elegant. It really all boils down to just two main parts.
Now, this is where it gets really cool. The way a GLM thinks about risk is by splitting the world in two. On one side, you have the systematic component. This is all the stuff the model can explain with data. Like the fact that younger drivers tend to have more accidents. That's a pattern. On the other side, you have the random component. This is just everything else. Pure chance, a bit of bad luck, stuff they just can't measure. And the whole game, really, is to make that systematic, predictable part as big and as accurate as they possibly can.
So deep down in the math, the model is basically just doing simple addition. It starts with a base level of risk, and then for each of your personal details, it just adds a little bit or subtracts a little bit. But here's the catch. That's not how insurance prices work in the real world. Think about it. If you get a speeding ticket, they don't just add a flat $50 to your bill. No, they add a percentage, right? Like a 10% surcharge. Real-world insurance rates are all about multiplying a base rate by different factors. So we have a problem here. The model thinks in addition, but the business works in multiplication. That's a pretty big disconnect. And this is where the magic happens. To solve this problem, actuaries use this really clever mathematical trick called a log link. You can think of it like a special translator. It takes the additive world inside the model and perfectly converts it into the multiplicative world of insurance pricing. It is, and I'm not exaggerating, the secret sauce that makes GLMs the perfect tool for this job.
Okay, that was a little abstract. Let's make it real. We're going to walk through a specific example right from the source material to see exactly how this math turns into actual money.
So after the GLM does all its number crunching, it spits out a table that looks something like this. See that intercept? That's kind of the starting point, the base level of risk. Then each coefficient tells you the exact impact of each factor. So in this example, every extra year of age adds 0.1 to the score. And being married, that actually subtracts 0.15. Interesting, right?
Okay, now remember that log link translator we talked about? This is where it does its work. We can now turn those additive numbers into factors we can multiply. So we start with a base value from that intercept. Then, let's say we're pricing a 25-year-old married driver. We take that base value, we multiply it by their age factor, and then we multiply that result by their marital status factor. See? It's all multiplication now. And voila, there's our number. The model predicts that the average cost or severity of a claim for a person with this exact profile is going to be $3,463.38. Now, this number isn't the final premium. It gets combined with another prediction for how often this person might have a claim, and that becomes the foundation for their actual insurance rate.
But hold on, it's not quite that simple. You can't just dump a bunch of data into a machine and walk away. There's a really critical human element here, and these models, well, they have some important limitations we need to talk about.
Yeah, just like the source material says, building these things requires a delicate balance of art and science. The people who build these models, the modelers, they're making dozens of judgment calls. Which factors should we even look at? How should we group them together? How do we make sense of what the model is telling us? It's really more of a craft than you might think.
And yeah, the models are not perfect. For one thing, they can really overreact to small bits of data. Let's say there's a tiny group of people and only a couple of them file a claim. The GLM will look at that and treat it as a 100% certain fact, whereas a human actuary might step back and say, maybe that's just random chance. They also have this built-in assumption that every claim is a totally separate event. But we know that's not true, right? A single hurricane can cause thousands of claims all at once.
So what's the big takeaway here? It's this. GLMs are ridiculously powerful tools. They allow for super precise, data-driven pricing. But at the end of the day, they are just that. They're tools. They are not crystal balls. They're built on a bunch of assumptions, and they absolutely require an expert human with good judgment to make them work effectively.
And that kind of leaves us with one last big question to think about. We know these models are getting smarter and more complicated every single year. They're getting better and better at predicting risk. But as they get smarter, does that automatically mean they're getting fairer? Now that is a question that goes way beyond just the math.